move to formulas and naming. So, what is chemical formula? So, we know and we saw a lot of it everywhere, anywhere. When you look at your shampoo, you can see that at the back. Cologne, food that you eat, if you look at the back, the ingredients, you can see chemical formulas and also chemical or the name of the compound. So, that is the use of this. Chemical symbols, so may L. And we will use here is the molecular formula and the empirical formula. So, what is the difference between these two? So, molecular formula is the exact number of atoms of each element in the smallest unit of a substance. And then the empirical formula, that will be the simplest whole number ratio of their atoms. Remember that the empirical formula will not describe the compound. It is just the simplest ratio of its atom or of its compound. Okay, so the other chemical formulas that you might encounter, condensed formula. Why condensed? Because it is text-based and you can see the different elements. And then the displayed formula, the difference between these is, as you can see, the bonds between the different elements or atoms. And here another is the structure or formula. And here we cannot see all the bonds. So it is just connected with the major chain, which is here the carbon chain. And then we have here the skeletal formula. So this one class, the last one will be commonly used in college. So you will draw a lot of this skeletal formula. Okay. So for molecular formula class, so we will use ball and stick model in identifying the formula. So for example, here I have a methanol, and let's find its formula. Okay, what are the rules? First is you have to identify the elements present in the compound. So you will see that this has a component of carbon. You can see a carbon. And we have an oxygen here. And then we also have a hydrogen here. With that, you have to identify how many atoms are present in the compound with each element. So for our carbon, we have one carbon here as depicted or shown as a black circle. And we have oxygen. We have here also one. And for our hydrogen, we have 1, 2, 3, 4 hydrogen. Now we have to follow step 3. So you must follow how atoms are joined in the molecule. With this one, our main attachment will be the carbon. So when you write it, like the molecular formula, so we have C, as we have here one atom, we don't need to write the subscript. Then we have H, 3. Why H3? Because as you observe, 1, 2, 3, which is connected to the carbon. And the other hydrogen is connected to the oxygen. So when you write it is CH3OH. So you now can see why it is called methanol from the term alcohol, ol. So when you will know the functional group of a compound if you heard the ol. Okay, isopropanol. Okay, that is why it is an alcohol. Okay, so this is the molecular formula of the compound methanol, CH3OH. Now let's move to another example. How about this one? So this one is nitrous oxide. Another for the rule. So what are the elements? We know we have nitrogen and we have the oxygen. So in each element, how many atoms? For our nitrogen, we only have 2, 1 and 2. And for our oxygen, O, we have 1. And you have to follow the attachment of the atoms. Okay. So how will we write it? So the attachment, main attachment is this nitrogen. Nitrogen, 2, as we have here 2 atoms of nitrogen, and then oxygen, O, which here we have a 1 atom of oxygen. So this is the molecular formula of nitrous oxide, N2O. Okay. So how about the molecular formula of chloroform? So try this one, class. So by following the 3 steps, first you need to identify, you need to identify the elements. We have carbon, hydrogen, and we have chlorine. Now let's identify how many atoms are there in each element. For our carbon, we have only 1. And for our hydrogen, we also have 1 here. And for our chlorine, we have 3 brown circles here. So 1, 2, and 3. So we have 3 atoms. So when we write the molecular formula, how will you write it? Put your answer in the chat box. So remember that the carbon and hydrogen are always together or near. Okay, very good, Yanina. Okay, how about the others? Okay. Okay, very good, Yanina and Shermel. So, that is the correct molecular formula of chloroform. So, carbon, then we have 1 atom carbon, and then also 1 atom of hydrogen. And for our chlorine, we have Cl, and then 3. So, this is the molecular formula of our chloroform. Okay, very good, Aaron. Now, let's go to the empirical formula. As we know, empirical formula is the lowest ratio of the molecular formula. So how do we do it? For here, class, we have acetylene. And acetylene is composed of carbon and then hydrogen. In our molecular formula, if you remember again the rules, so remember the number of atoms, okay? So we have 2 atoms, and then also we have 2 atoms of hydrogen. And with this, we will have a molecular formula of C2H2. How about the empirical formula? Now, what is the lowest ratio of 2:2? So we will just divide the smallest number, or the smallest ratio, or smallest number, which can we see in this subscript. So 2 and 2. Therefore, the empirical formula of acetylene is CH. Because we just divided C2 divided by 2, then H 2 divided by 2. So that is how we get the empirical formula of CH. How about if we have here the glucose? So glucose is one of carbohydrates that we need in our body. So we have carbon chain, carbon atom, hydrogen atom, and oxygen atoms. So remember our molecular formula. So we have carbon. How many carbons do we have? So let's count. 1, 2, 3, 4, 5, 6. So we have 6 carbons. And then for our oxygen, 1, 2, 3, 4, 5, 6. 6 oxygen. And for our hydrogen, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So our hydrogen is 12. So how will we write our molecular formula? So remember, you just have to copy this value here. So that will be your subscript, and it denotes that it has, or it is 6 atoms. Then we have here hydrogen, which is 12, and then oxygen, which is 6. Can you write the empirical formula in the chat box? What will be the empirical formula of glucose? Okay, so very good, Shermel. So very good, Shermel. Okay, so we have here, okay, there we go. So C6H12O6. So remember that we need to divide it by the lowest ratio, or the smallest number that we have, which is 6. So when we divide it, we will have C, carbon, carbon, hydrogen 2, and then oxygen. So this will be our empirical formula. And also Aaron. Okay, very good, Aaron. Okay. Now, try this one, class. How about the empirical formula for caffeine? Okay. First step is our molecular formula. We have carbon, nitrogen, oxygen, and then hydrogen. For our carbon, okay, try solve this one, class. Okay, let's try. So you can follow. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbon. Let's count again. 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 carbon. And nitrogen, we have 1, 2, 3, 4. 4 nitrogen. And our oxygen is 1, 2, 2. And our hydrogen, 3, 6, 9, and then 1, which is 10. So in writing the molecular formula, that will be C8, then our H, hydrogen, 10, and then we have here our nitrogen, which is 4, and our oxygen is 2. Can you write the empirical formula? Write it in the chat box. Okay. Very good, Shermel and Aaron. That is correct. So, how do they get it? So, we have here the smallest subscript or number, which is 2. And also Marwin. Karil. Okay, so you are all correct. So, we have 2. 8 divided by 2, we will have C4. 10 divided by 2, we will have H5. And N, we have 2, and we will have for our oxygen. So this is our empirical formula. Okay, now let's move to bonding. Now that we know how to create a formula, now how will we know how do they bond? So when we form a relationship, we know how to make friends or make a bond with other people. So same with the molecules. So they are attracted because they have the same properties, or they are attracted because, as we know in chemistry, opposite attracts. And that is how molecules or atoms behave. So let's have here chemical bonding. As we know from the term bonding, it is the attraction between an atom and a molecules or a molecules. Then we have two bonding. That is 3, which I did not include the metallic bond as it is not yet important. So let's focus on these 2, covalent bond and the ionic bond. So when we say covalent bond, this is the relationship formed between 2 nonmetals. Okay, remember 2 nonmetals. When you look at your periodic table, you will easily identify which is nonmetals. And then we have the ionic bond. So this ionic bond is formed between the relationship between metal and a nonmetal. So this is opposite attracts. Okay. For ions class, we will put ions in ionic bond because there are atoms that has a net positive or a negative charge. And this one class, before we go there in ions, let's explain this type of bonding. So what element is this class? So we have one proton and one electron. What element is this? Write it in the chat box. What element is that class? Okay, very good, Shermel. That is hydrogen. So this one class is 2 atoms of hydrogen. And this class, when they are attracted to each other, they will form a bond. And this bond is called hydrogen bonding. So class, this hydrogen bonding is present in our body. It is also found in our DNA, hydrogen bonding, and a lot in organic molecule or organic structure. And this bonding is called covalent bond. And you can remember it by saying sharing is caring. So they share their atom with each other, their electron to each other. So you can see they follow the rule that this one, this first orbit, will have 2 atoms. And that's it. They satisfy each other. So that is covalent bond. Now let's have another example. How about this class? There you go. That is a chlorine. Why it is a chlorine? So when you count the electrons, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And when you look at the periodic table, the atomic number and electrons are equal. So 17 is chlorine. And then we have here, and this chlorine gas is not stable. Why? Because it is missing. It missed someone. So that is why we have this tendency to find friends, to find someone we want to be with, because we feel lacking. We are not stable. Okay? And then we have this hydrogen, and this hydrogen will complete this compound or this loss. And this one is called hydrochloric acid, HCl. And this one is now stable. So when they combine, when they are sharing their electrons, they are now stable. Okay, how about this one, class? Can you identify what element is this by counting the electron? Okay, very good, Aaron. That is sodium. So why sodium? As you can count, we have 2 and then 8, 10, and 11. And the representative of 11 electrons, 11 protons, and 11 atomic number is sodium. Okay. And this one, same as a previous slide, that is a chlorine. And this one, class, is not stable. Why? As we know, it lacks an electron, and to satisfy the octet rule, okay, meaning that the shell must have an 8 electron, at least in the third orbit, second to the third, second and to the other orbit, and so on. Okay? So they're not stable. And then when they combine and the sodium share its transfer its electron, transfer is the term, class, not share, but transfer the electron, then that is ionic bonding. So we can say it as a give and take relationship. So that is the key, okay, of a relationship, is it? So it really depends on the people. So give and take relationship. So now, this one is already stable. So why it gives its electron? The sodium, when it gives its electron, it will be slightly positive. And then, that will be called a cation. And then, this one who receives the electron will be slightly negative. And now, it is an ion. And that is, it is transferring of an electron. As you can see, class, this third shell will be removed, and then this second orbit or shell is following the octet rule, which is already stable. So this is how metals and non-metals bond to each other. Okay, so you can copy. For our group 1, we have 1 plus, 2 plus for group 2, and then 3 plus here in boron group, then carbon group, nitrogen group, chalcogens, pnictogens, and then we have the halogen and noble gases. Okay. And for our transition metals, there will be different as they have a lot of oxidation state. Okay? Why a lot? Because some of these class are made in the laboratories. Some are found in our environment. So that is why it has a lot of oxidation state. Okay, before we go and name and create formula, let's identify this one first. We know what is ionic bonding, and now we know what a ionic compound. So it is between metals and nonmetals. For our rules, to simplify this one, first, okay, let's have an example, lithium bromide. With this one class, first is to identify the element's oxidation state. So the lithium has what oxidation state? Okay, lithium. So we have a positive 1 oxidation state. And for our bromine, we have an oxygen state of negative 1. With this class, if the charges are equal in numbers, we have 1 and 1, meaning when you add this one plus 1 minus 1, you will get a charge of 0. Therefore, you don't need to put a subscript. Then you will just follow how it is named, lithium, and then bromine. Okay. Remember also, class, that metals always at the first. Then, the second word will be the non-metal. Okay? Remember that. So, next is magnesium iodide. Same process. Write magnesium. What is its oxidation state? That will be positive 2. And then, how about iodine? Iodine has an oxidation state of negative 1. With that, they are not equal. So when they are not equal, you have to crisscross, which is easy. Therefore, the subscript of magnesium will be 1. You don't need to write it. And then for our iodine, we have 2. So this is magnesium iodide. Now, let's have another example, aluminum oxide. Okay, so it can be seen it like this. So A will go to Y, and then the B will go to X. And the aluminum is positive 3, and our oxygen is negative 2. So the negative and the positive charges will not affect in the naming, okay? So you have to crisscross because it is not equal, and aluminum, which is the metal first, we have 2. Then we have oxygen here, which is 3. So this is how we name ionic, write the formula, chemical formula for ionic compound. Okay. Next is, how about if we have polyatomic ions? So when we say polyatomic ions, class, this is composed of different atoms. So 2 or more. No, 3 or more. That is why poly, many. So you can look at the back of your periodic table and you can see all of the polyatomic ions. We have D anions and D cations. So we will just look here in ionic compound, D anion. Okay, so for this class, polyatomic ions, you have to familiarize and memorize some charges and the names and formula for this one. So next is to identify again oxidation state. If equal, you don't need to write subscript. And if it is not equal, you have to crisscross, and then that's it. Let's have an example. We have calcium. What is the charge of calcium? Calcium is positive 2. Then we have the carbonate, CO3, at the back of the periodic table, if it is at the front, okay? Carbonate. Okay, so it is negative 2. So this one class, they have the same charges. Therefore, you will just write calcium CO3. So this is the formula for calcium carbonate. For the next one, we have sodium hydroxide. So how? Look at the table, periodic table. Sodium. What is the charge of sodium? We have here Na, positive 1. And then for our OH, look at the back. Hydroxide is negative 1. Therefore, when you write it, it will be cancelled. So it is NaOH. Now let's move to activity. Ionic compound. Thumbs up if you don't have. Okay, so let's move on. Okay, so for naming naman of ionic compound, so let's have type 1 and then type 2. So what's the difference between these two is the cation or the number of oxidation state of each element. So for example, we have type 1. What is the rule? So name of metal plus stem name of non-metal plus ion. So for example, we have here Ca, which is calcium. And then we have chlorine. So calcium and then chlorine. Remember that this is type 1 and we have to get the stem name. So the stem name of chlorine is chlor plus I. So when we rewrite it, that will be calcium chloride. Okay. How about here, sodium and then iodine. So sodium, iodine. So the stem name of iodine is iod. So when you rewrite it, sodium, iodide. Okay, so this is how you get the name of a chemical formula. So let's go to type 2. What is the rule? So here we know the traditional naming, adding the suffix of "-us" and "-ik". When we say "-us", that is or has a lower oxidation, and "-ik" higher. So for here class, it is copper. We have copper and then oxygen. So remember that here the oxidation number in numeral of our metal. So what is the oxidation number of copper? Here we have copper. So we have here 1 when you crisscross it. So this one will have a copper 1 oxide. How about if we answer, then we have here Fe, which is iron, and then chlorine, iron, and then chlorine. So what is the oxidation state of chlorine, iron, which is 2. So when you write it, it happened. So when you write it, iron, its oxidation state in Roman numeral, we have 2. And then chloride. So chloride. So iron, chloride. So for polyatomic ions, we have also rules. So this is easy. You just write the name of the metal and then write the name of the polyatomic ion. For example, here class, we have calcium and then cyanide. So when you look at the back of your paper, we'll just write it as is. So calcium, cyanide. Okay. For here we have iron and then NO3 2, which is NO3, meaning what is NO3? It is nitrate. So we have iron, nitrate. The oxidation state and then the nitrate. Okay, so this is how you name polyatomic ions. Okay, type 2 with polyatomic ions, we have metal cation, which is iron, then its oxidation number in Roman numeral 2, and the name of the polyatomic ion, an ion. So for the naming, let's try this one, the formula. Okay, bear with me. Now let's go to covalent compound. So when we name covalent compound, we have type 3. Remember, nonmetals to nonmetals, and we have prefix. And rules, we have prefix for nonmetal first, and then the second nonmetal, we have also prefix and then I. So for example, here we have potassium and we have chlorine. So we don't need to write a prefix because we don't have one here, a subscript. We don't need to say mono, phosphorus, but we just write it phosphorus, chloride. Is it tetrachloride or chloride? So we have here a subscript of 3. So not tetra but trichloride. So the prefix is followed by the subscript. Okay? Remember that. Phosphorus, trichloride because it is 3. Now let's go to, to nitrogen O4. How about nitrogen? We have now a subscript of 2. Therefore, you have to add di. So, di, nitrogen, O, which is 4, and 4 is tetra. So, there we go. That is the tetra. Tetra, then oxide. Okay. So, for here, one class, in polyatomic and other naming, you have to familiarize these different names. So, they're not based from the elements, the naming. So, you will learn it as you go on. Why it is ane? Ane because it has one bonding. Alkane, alkene, and alkyne. Okay. So, there we go. So, methane, silane, ammonia, phosphine, water, hydrogen sulfide. Okay, so let's try this one.